Hi, welcome to Coding Bootcamp's YouTube channel. Subscribe now and join our live stream session later. See you.
Welcome to coding-bootcamps.com. My name is Carlos Vieira, and I'm going to be taking you through an overview of an introductory course to the C++ programming language. As I mentioned, you can find us on coding-bootcamps.com, on your favorite social media platforms, Twitter, Facebook, LinkedIn, YouTube. So make sure to give us a follow, and let's get started. So as I mentioned, this is going to be an introduction to the C++ programming language. About myself, first, I'm a junior software engineer. So initially, I taught myself HTML and CSS at a young age. I guess a bit cliche. And then I went on to embark on a university pathway to attain a bachelor degree in computer science at the University of Northampton, UK. So I am based here in the UK at the moment, and computing has always been, from the very beginning, one of my main passions. Currently, I work for a home automation company called Indigo Cest, and what I do there is provide and maintain a number of web API integrations, and that basically means that mm, I'm helping different apps talk to each other and work together to automate a number of workflows within the company. So that's one of my main roles there. And I've volunteered before at my local community just to give back and helping them with building of their websites. Mainly, I'm adept in Java, C++, PHP, MySQL, HTML, CSS, and one of my favorites, JavaScript. So that's mainly what I'm using at the moment. But I'm learning every day new technologies and new languages, and that's one of the exciting things about computing. So prerequisites, there are none to this course. This course is aimed at beginners. So if you've never programmed before and you're just starting out, this is perfect for you. We're going to cover the basics and the fundamentals to get you well on your way to becoming a pro. What topics are we going to be covering, right? This is a high-level list of those main topics, and they're going to be C++, object-oriented programming. So obviously C++ is a programming language, and then object-oriented programming is a way to structure programs. We're going to look at fundamental types. So how do we store data within the program? What are the different data types? And how can we interact with them? And names, and also keywords and variables. So like an actual regular language, right? C++ and programming languages, they have their own set of rules. And these can be grammatical, as in the form of syntax, or they can be in the form of keywords or defined words, such as the ones that we use to actually write the program. And then we can also define our own words within the program. So I'm going to teach you all about that. I'm going to teach you about the arithmetic operations that are powered by C++. So how can we manipulate numbers within C++, perform calculations? How can we do that in the most effective way possible? If, else if, nested if statements with examples. So how do we make decisions within the flow of that program? Okay. Next, we'll look at switch cases in C++. So again, that's related to decision making within the program. And for, while, do while, and nested loops. So how do we loop code within our program? Right? Something that we're gonna look at to avoid repetition. We're gonna look at structures within C++, so building more complex structures to make our programs more robust and organized. And we're gonna do a project that we'll go over it together, but it's basically a program to calculate the age of a human by entering the date of birth and the current date. And lastly, there will be plenty of homework. So there's going to be 3 main homework sections that come with 11 exercises that we'll all cover together. So what's the takeaway? What am I going to learn by finishing this class, right? And you should think of it as this is going to be that jumping board to get you to the next level in your programming career or your computing career. So you're going to take away the fundamentals of not only C++, but many of those concepts that are applicable all throughout computing, all throughout all sorts of programming languages. So this is really fundamental. It's really important. If you are new to programming, sign up, and this is going to push you to that next level. Okay, you're going to be able to program your own applications, so build your own scripts to do all sorts of things, because you have the main tools at your disposal. Okay, so with those fundamentals, with those basics, you actually be able to do quite a lot before you even start to get into more advanced topics. So you'll learn, for example, how you can tell the program to do a certain task multiple times depending on the user input, right? So rather than you having to type out a specific task 100 times, you can go in and tell the program, do this 100 times if this and this happens, right? So you can start to orchestrate a series of actions or or processes within a C++ program. And we're going to cover that. We're going to cover how you go from code to an actual executable file and why we even need a compiler, right? I'm sure you've heard of the compiler, and I'll explain to you what that's all about. We do offer private tutoring sessions on the platform. So at any point along the way, if you feel that you need additional support, right? We do have the additional content available online for you to look through. But if you do feel at any point that you need just that tiny bit of extra help, we can offer that for you. We offer weekly and monthly private tutoring plans. We can cover a variety of topics, not only C++, but the C language and other programming languages. So just stay tuned for that and check out the platform for the latest private tutoring plans. Next classes after this will be the immediate level C programming language with hands-on examples, an introduction to C programming as well. And there's plenty of classes, plenty of learning to do. So do sign up. And thank you very much. That's it for today. Hello and welcome to coding-bootcamps.com. My name is Carlos Vieira, and I'll be taking you through session 1 of our introduction to the C++ programming language. So we'll be going and having a look at an overview of C++ and object-oriented programming. There is no prerequisite prior to the taking of this course, so please feel free to take things at your own pace and take advantage of the course material that we have provided. We'll be looking at the development and properties of C++, characteristics of C++, translating a C++ program. So how do we go from the actual code to an executable file? And then lastly, we'll be going over 2 sample programs. Starting with the characteristics of C++, one of the main defining ones is that C++ has all of the features that are available in C, meaning it was designed to expand on the functionality of C, which is an programming language that existed before C++. It's also one of those fundamental programming languages, so it's definitely one that you should be aware of. If you'd like to learn more about C, you can check out our course on the platform. The next characteristic is that C++ is used to build universally usable modular programs. It's also very efficient, very fast, so it's known for having high computational power. And this is due to the fact that it's close to the machine programming of the computer. So it's very close to the language that the computer already understands. Therefore, it has to do less translating. We call this low-level languages, right? And then the next one is that it allows for the creation of portable programs for various platforms, meaning you can use C++ to create a wide variety of programs for a wide variety of devices. C++ supports the concept of object-oriented programming, unlike C, meaning that it allows you to have a set of tools and ways to build more complex programs. Some of these key concepts are listed on this page, and they are supported by object-oriented programming. You don't need to know each of these concepts in depth yet, but it's a good idea to start familiarizing yourself with the terms. So you have data abstraction, so the creation of classes to describe objects and how they behave. This is sort of like creating a blueprint. Data encapsulation, and this is all about controlling access to the data held within an object, whether it's in terms of changing that data or reading that data. Inheritance, this is when you create a class that derives much of its behavior and functionality from another class that already exists. So it's almost like we're borrowing that behavior without having to repeat the code or copy it, and then we can expand on that behavior in our new class. That's inheritance. Polymorphism is when you have a set of instructions within the program that allow it to respond to an object in a way that is unique to the type of object. So you can have, for example, an abstract class called shape, and then you define other classes that implement shape that are, for example, square, triangle, circle, and they each have their get area class. The program will look at the object, whether if it's a triangle, and then it'll determine the area of the triangle using its function. If it's a circle, you'll use the get area function of the circle class. So that's about it. And don't worry if you don't understand everything so far in detail. Get the hang of it, but it's just get familiar with the terms. Next, we'll look at procedural programming. Now, what is procedural programming? When we start programming, we have to start thinking about and being aware in general of the many different ways in which we can structure a program, right? The form, we normally call this a programming paradigm. And procedural programming is the first one that you'll come across because it's the most simple of them all, really. And it means that you structure your program using procedures, and these procedures are executed in a specific sequence. And it's all about just, for example, giving instructions. Okay, first do this, then do that, do that. So it's always following that same order, top to bottom. So we call it a top to bottom approach. And that's really the gist of it. There's not a lot of organization of that code going on. You basically have to ensure that your variables are initialized before you go ahead and use them, and then the suitable data is passed to the functions when called. And then if the data representation is changed, or for example, if a record is extended, then the corresponding functions or any logic that accesses that data passed along the program, it has to be updated accordingly. So that's procedural programming. And that takes us to object-oriented programming. Now, with object-oriented programming, we fix a lot of the problems with procedural programming that we come across if we start to build a larger, more complex program. Because if you build a small program, you might not notice many of these things, but once the scope of the program expands, you start running into these problems. So the first one is reduced susceptibility to errors. So an object controls access to its own data, and because it controls that access, it can also perform validation. So if you try to change the data in an object and you try to put in data that is invalid in relation to that object's rules, then the object can simply come back and reject that change. And we normally do this through what we call mutator functions. So we define a function inside that object that takes in changes, and then it can validate those changes. The next one is reusability. When we look at objects, we can think of them as an encapsulation or a grouping of data and logic. And because we have that logic encapsulated and put away from the rest of the application, it means that we can reuse it in for example, in other applications. We can, if someone else has written for example, a better class of the one that we're going to use, and it already exists, we can go ahead and use that one, bearing in mind, of course, that we have permission. But you can use the same class throughout your program in other programs, and that's the benefit of encapsulation. That you don't have logic all over the place, and it's stored neatly into one class. The next one is low maintenance requirements.
Thanks for watching. Feel free to add your questions as comments down below.
So because an object can modify its own internal data representation, then we don't require the application to take care of this on a global level. So if you enter data into an object, the object can take care of how that data is stored and represented, and the application doesn't need to worry about that. You encapsulate that logic within that object. Okay, so now we can talk about how do we go from a C++ file, right, to an actual executable, because we have to remember that the computer doesn't understand C++. It doesn't understand, it's a foreign language, it doesn't understand it at all. So there's 3 steps involved, and the first one you'll be familiar with perhaps is just the use of a text editor where you can write and save your code. This can be a development environment. In other words, we say that this is the source code and it's saved to a source file. In larger projects, you normally have more than one source file, and then this is what we call modular programming. You could have, for example, one file per class. So you have multiple files, and it makes it really easy to go back and make changes because you don't have to open up the whole thing or read thousands of lines. You just focus on what you're working on. So this means that the source code is stored in several files, and they're edited and then therefore translated separate. So that next step is going to be translation, and it's completed by what we call a compiler. So a compiler takes the source code, the C++ language code that we've written, and it translates that into an object file that is made up of machine code. This object file can also be referred to as a module. And that third and final step involves the linker. So the linker combines the object file with other modules, and it gives us that executable file. These further modules contain functions from the standard libraries or paths of the program that have been compiled previously. So if we just recap that, we go from the source code, then the compiler, and lastly the linker. Make sure as we go along that you are caught up and reading all of the course material that we have provided for further details and to further instructions as well. Now that we've gone over some of the basics, let's get started and actually have a look at the code, right? Let's go through some C++ code. And this is our first sample program. So I'm going to go through it line by line. You don't need to worry about remembering the syntax too much. That's going to come as we look at more programs. But let's get started with the first line, which features the hashtag include IO stream. Now this is what we call a preprocessor. Now what is that? What does that do? That allows us to have access to code or information that is stored in a separate module or a separate file. And that's great because we don't have to repeat that code in our file. We can access that information by using an include statement, and then we put the name of the module. Then you have using namespace std, or using the standard namespace. When we write this, what we instruct the compiler to do is look up at the namespace in order to understand our code. You can think of it as a dictionary or a naming convention. So in C++, you have various reserved names for variables, classes, constants. And for the compiler to understand what we mean, we just basically specify the namespace. So it's really important to have that before the block of code that we're writing. And next, we have the main function. So you have, first of all, the return type, integer. Then you have the name of the function, open parentheses and closing parentheses. Then you have an opening bracket and a closing bracket over here, and the body of the function is encapsulated in here. So first line of the function is cout, and then the arrows to the left, enjoy yourself with C++. arrows to the left, and then end L. Now, what do you think end L means? It actually means end line. So we are adding a line break. The left arrow separators are just separating the elements. And we have cout, which prints the console log. So that's basically printing the text on the console. In order to use cout, we have to have access to the IO stream. And this is why we included this preprocessor. The next and final line is that we return 0. Normally, in the main function, we have to specify that we are returning 0 here. And basically, the compiler knows that once it gets to 0, there hasn't been any issues. That just tells you that there has not been any problems in running your code. That's why we have the ints as the return type, because 0 is an integer. Another thing to bear in mind looking at this program is, why do we call it main? And could we call it anything else? And you might think back to the fact that we can write a program with many modules, right? How would the compiler know where to look, right? Or how would you know where the program would start? And this is why we have main. Main is the first function that gets run in the program always. You can have other functions, but you have to start with main. So that's something that we have to have. You need to have main in order to create that program. Now we're going to look at a more advanced program. Many of the elements that are here we've covered already. So we'll focus on those that we haven't. You start with your include line, the namespace. Then you have void line function, message function. This is what we call a prototype. Now, I'll tell you in a moment what we mean by prototype. Just bear that in mind. We go into the main function. You've seen this already. You know it. You print out hello. The program starts in main. And then you end the line. And then we have this line function. Now you, or even the compiler looking at this code, you'd get to line and you forget the rest. You don't know what this function does, because as far as we know, before this point, we haven't defined it, right? We don't know what the line does. And we wouldn't be able to use that function if it wasn't for the prototype, because the prototype basically tells the compiler, hey, listen, I've got this line function that I'm going to be using quite shortly before it's defined, and also this message function. Therefore, by putting that in, by the time you get here, the compiler is ready, and it can go ahead and go up to the line function. It'll print out a horizontal line. Then we go back to the message function. We print out this message. We go back to the line function, print out the line. And then lastly, we print out this message here and then a line break. And we return 0 to signify the success of the program. Okay? Next, I'm going to briefly show you how to get the development environment that you'll need in order to start writing C++ programs. I'm going to show you the one I'll be using on my Windows machine. So for that, we go to the browser. You want to head over to visualstudio.microsoft.com. Once you're there, go to Downloads. And you have to look for Visual Studio 2019. We're going to be using the free community edition. It's open source, available on Windows, and should also be available on Mac. And then just download and follow the instructions and just have it ready to go. Okay, so let's have a recap now and think about what we've learned so far, right? So we looked at those characteristics of C++. If someone were to ask you now about C++, you'd be able to at least give them a description about what makes C++ unique and some of its main benefits. You'd be able to talk to them about object-oriented programming and why we prefer, generally speaking, in many cases, object-oriented programming to just simply procedural programming, and how important it is to organize logic and data in classes wherever possible. We've also looked at the translation of a C++ program. How do we get from code to an actual file that we can execute? And then lastly, we actually started looking at C++ programs and dissecting that code line by line. For the next sessions, we will switch to more of a hands-on approach, more practical examples and such. So we will teach you how to write C++ code, and you'll be able to run this code in your the development environment, the one that you've downloaded, and all of the material, including the source code, will be available on the platform. So make sure to check that out. Next session will be focused on the C++ fundamental types. Those are data types, names, variables, and keywords, all fundamental. On another note, I do want to point out, if you do find yourself that you're going through the additional support material and you do find yourself struggling, or you're not moving along as quickly as you'd like, you can always sign up for private tutoring. We can offer that for you, not only for C++ or C, but other languages. So do check out the platform and see that the weekly and monthly plans that we have available for you, just to get you back up and moving. So if you do find yourself stuck, there is help, and just reach out to us. And that's it. Thank you so much for joining our first session. Welcome once again. This is session 2 of our introduction to the C++ programming language. We'll be looking at fundamental types, constants, keywords, and variables all throughout by reviewing 5 sample C++ programs that we've put together for you. Now, before each program, I will review the main concept, but for a more detailed explanation, I do recommend going over the support material that we have provided. If you want to run the code on your machine using the development environment just to make sure that it's working, you can feel free to do so, but bear in mind that the main focus of this session will be on getting those fundamentals right before you can start writing your own code in the following sessions, which will be fully hands-on. Let's get started then. We have here the overview of the fundamental types. You have Boolean, which is normally true or false. And then for characters, you have char and wchar. Then you have integers, you have short, int, long. And then lastly, you have floating point values, which is float, double, and long double. And you might be wondering, what's the difference between all of those? Why can't we just store things in just one type, right? And that's because they each have a different size and a different range of values that they can represent. As you can see, char is quite small. You can only go from -128 to 127, or 0 to 255. Now you can have a specific char, which would be an unsigned chart or a signed chart, in which case you limit that range. So unsigned chart is 0 to 255, and then signed chart, you include the negative numbers. If you look at int, you have it can go from 2 to 4 bytes depending on the size of the decimal number that you want to represent. Or you have the unsigned int, which is only positive values. And here we have our sample program. So looking at the sample program, we start with the preprocessors at the top. So we have to include statements for 2 modules that we're accessing. The IO stream we were talking about in session 1, as you recall, is for input and output into the console, right? Then we have C limits, which we have a comment right next to it. As you can see, that comment starts with 2 slashes. This is a single line comment that will follow through the end of the statement. So it says this is the definition of int max, etc. So this, we know that it's going to define the int min and int max constants. We have this one here, so int min and int max. And you'll see that the comment ends with the semicolon. This is something that we haven't talked about yet, but every statement, every instruction will normally end with a semicolon. This is how we let the compiler know we're done with this instruction, okay? That's something to bear in mind. And then afterwards, we jump into our main function, which we've discussed before. So you should remember we have the integer return type, the main, which is the function name. Then we have these 2 parentheses. Now, these parentheses are not necessarily there for no reason. It's something that is required in the body of every function, right? And when we have those 2 parentheses, normally what we put in there are called arguments.
If you have enjoyed watching this video, please subscribe to our YouTube channel. Thank you.
But in this case, the main function does not take in any arguments. And what are arguments? Argument is data that is passed into a function. We'll cover that in more detail later on, but for now, you just need to know that these two parentheses, the opening and the closing, is to hold arguments for that function. And as we don't have any in this case, you just open it and you close it right away. Then you have the opening and the closing brackets, and inside, this is the interesting bit. This is where we have the body of our function. We start with cout, and then the separator here. And now this here, these two arrows to the left, this is called the insertion operator. So it does separate. For example, you have here a string and then you have two line breaks. It does separate those. But primarily what it does is it sends information to cout. And cout, what it basically does is it prints out the console. So it's something to bear in mind. The direction of the arrows is important because it basically works with cout. It's an operator. Now, in here, we are outputting the following message, range of types int and unsigned int. Then we have two line breaks, and then that semicolon again that I was talking about. So we are ending the statement. So as you can see, there's no semicolon up here. So this entire line is one statement altogether, even though we've split it into two lines. Then we go on to print type, minimum, maximum. Okay, then we do a line break. We print a line, another line break, and then here we print int. And now this here is a constant. Normally constants are defined in capitals, and a constant is generally a variable that has a value which does not change. Okay, so this is coming from C limits. It is defined in this module. So in this case, this would get printed out, the minimum size of that integer, the minimum number, and then the maximum number of that int. Okay, and then for unsigned int, you get it printed out down here. It starts with 0, and then it would print out the maximum of basically unsigned int. And for that, just refer to the table above. And then you get a line break. And then lastly, we end up with return 0, which would basically communicate and signify that the function or the program has run successfully. Moving on from this, we have the table of floating point types. So again, it's just going over the differences between the types of floating points, just minimum values that can be represented, maximum, and then the decimal point accuracy. That leaves us with two arithmetic types, the integral and the floating point. So now that we get to constants, the best way I can explain constants to you is they are defined placeholders of values which cannot be changed. So they are defined in the beginning of the program, generally, and throughout the life of that program, even if other objects try to interact with the constant, or you write code to change the constant, it will not be allowed to change. And constants can be defined by yourself, the developer, or they can be predefined by the programming language. You have the examples here of 16 being able to represent 0 to 0 in the octal numerical system, or 0x10 in the hexadecimal numerical system. That's an example. Now let's see that in action in some real code. We've got our program here, starting with two one-line comments, just explaining quickly what the program is all about. That's always generally a good idea to include in your programs. You have the IOStream preprocessor, which right off the bat, we know we're going to be dealing with input and output. into the console. Now let's look into the body of the main function. And we have a comment here trying to explain what's happening briefly, but let's break it down. We start with cout, so we know we're getting information output into that console. We have value of 0xff, so this is a string, and then we're literally putting in 0xff, which, as you might recall, this is a hexadecimal value. And this is why we call it a hexadecimal integer literal. I'll explain in a second. And then we have decimal, but the output that you get is 255. So we put in the hexadecimal, which the program knows holds a value of 255 in decimal. And that's why it gets output. By default, cout is going to output into decimal. Now, let's look at the next line. And this second bit here is going to be a bit different, because if you read this properly, it says the manipulator hex changes the output to hexadecimal instead of decimal. Now, hex is a function. It's a function that interacts with the cout object to change that output from decimal to hexadecimal. So we have here the string value of 27 equals hex. As soon as we input hex in here, that changes everything. And then we just put 27. And as soon as we put that 27 next to the hex, that's going to be output as 1b. Rather than getting output as 27, is actually being output as 1b hexadecimal. And then we finish the program with the return line. And that's to signify again that it's run successfully with no issues. Let's have a look at some other more examples of constants, and we've got some here for floating point values. And we've also got constants that we can use for characters. So capital A, that will stand in for the 65 in the ASCII numerical system. And you have lowercase a, and so on and so on. And an interesting one that's here is called the terminating null value. Now, why does it actually terminate? It's used to terminate strings. And I'll show you why that's necessary. Let's say you're writing your code in your program and you're creating a string, or what we can also call string literal. You start with a quotation mark. You write hello, exclamation mark, quotation mark. And when that actually gets stored in memory, it will get stored as a sequence of 7 bytes. Now you might be wondering, why do we need 7 bytes instead of 6? Because we actually only have 6 characters. And that is because the characters themselves are stored in an array, or you can think of it for now as a list of items. And the program needs to know when that list eventually ends, essentially. And that's why it adds in a terminating null character. It's not something that you will need to worry about when you're creating a string, but you just have to be aware of it being stored in the actual representation of that string, essentially. So it gets added on in the end of that string. Now, what if we wanted to, let's say, add an additional quotation mark in here? Let's say we wanted to output this hello message, this hello string, in quotation marks, right? Because we need quotation marks to create the string, but they don't actually get output in that string. But what if we wanted to have those quotation marks as part of the string, right? Then it gets a bit tricky. And we have something for that called escape sequences. And these are special characters that stand in for other values that you can use in your strings without confusing the compiler. Because if you really think about it, let's go back to that example. If you For example, put in here a quotation mark, a second quotation mark. The compiler is going to think that there's no string, the string is done. If you put it here, if you put the second quotation mark here before this one, then the string will end early and you'll be left with another quotation mark outside with no match to follow. So the compiler will have no idea what you're doing with that second quotation mark. And that's how we can get around that. We use escape sequences. For example, for the quotation mark, we have backslash quotation mark, and that's going to give us that double quote there. So they normally start with a backslash. You don't need to remember or memorize all of them. The ones that you use commonly, you will automatically memorize, or you can always look them up. But let's see how they can actually get used in the program. So we start here with our preprocessor for inputting, outputting into the console log. We have the standard namespace and then our main function that will run our code. We start out with cout, so we're outputting to the console, and right away we have a string, but it looks quite robotic. It looks quite odd if you first look at it without being aware of escape sequences. But let's break it down. It starts out with \n, and \n is the escape sequence, if you look at the table, for a line break. So it's an alternative to using AND-L as we had seen in the previous programs. So we start with a line break, then we have this is, and then \t, and that stands in for a horizontal tab, which is what we have here. A string \n, so the line break, and then \t, so we have two tabs, which it's just lined up really nicely here. And then with \quotation mark many, \quotation mark. So this is what gets the quotes in here. Escape sequences, and then \n, and that's another line break, which obviously we can't see because it's invisible. And then return 0. That's it now for constants. Let's have a look now at what we call keywords. Now, keywords in C++ is essentially a set of names, for example, names that you would use to name a constant that you define, or a name that you would use to define function name. And these are words which are reserved in C++. Basically, they're predefined and they're being used for something else generally, and we cannot use them for our program in any way. So these are the reserved names, and they each, like I mentioned, they have an intended purpose generally, meaning that you cannot take that name and use it for something else, because that will, in fact, confuse the compiler. The compiler won't know what to do, and you'll normally get an error. As you can see, some of these we've already seen. We talked about namespace, data type names such as int, double. We looked at, let's see, wchar_t. So there are quite a few of these that we have seen already, and many that you haven't seen, but that you will definitely see later on. You don't need to memorize these for now. Normally, when you try to use them, the compiler will be happy to let you know that there's a problem. So let's move on, and let's see a few examples of what would be valid and what would be invalid. So we've got here some valid names. So for example, you could use set text color. This could be used for a function that changes the text color, of course. And you could use, for example, this here for a constant or a variable. We'll go further into variables later on, but you could use this to name a constant or whatever you wanted. And these are all valid names. And then we get some invalid ones down here. So if you were to use true, for example, generally we use true as the value for a Boolean data type, so it can be true or false, right? So if you started to name something as true, the compiler would look at that code and not know what to do. So it would trigger an error. And that's the way that you have to think about it.
Thanks for watching. Please like and share this video.
How is the compiler going to be able to interpret your code if you are using predefined values? And that's where the issues arise. So this is something definitely to bear in mind as you're coming up with names, and there will be a lot of that during the creation of your programs. Speaking of naming, something you'll be doing a lot of is naming variables. Now, what are variables? Variables are like constants in the sense that they are values that we can define throughout our program. The main difference is that with constants, you set that value early on and it can never change throughout the lifetime of that program. So from beginning to end, that value will remain the same. Whereas for variables, we can set a value and we can give it a name and we can refer to it throughout the program. And if we need to, we can always go back and change that value. So for example, let's say you're performing a complex calculation. You can go ahead and take that result, store it in a variable, and refer to it throughout the program rather than having to repeat that calculation every time you need to get to that value. So you save yourself the computational power, but also, if you think about it, really the mental power in terms of reading through that program and understanding its complexity. So there's tons of benefits to variables. And let's go through an example here in our example program. We start off with the preprocessor at the top. We declare our namespace. And then down here, we start right off the bat with the two variables that we're creating. So we have the data type of the variable, and then we have the name of the variable. Now you can see here it ends with a semicolon. So we know that that statement has ended and we haven't given that variable gvar1 a value. So this is called implicit initialization. And it's when we create that variable, we don't give it a value. It does have a value, which would be 0, but because we're not explicitly giving it a value, it's just going to take that default. The second variable here, gvar2, we are actually giving a value. So we're using the equal sign and then assigning a value on the right-hand side. Now, you can see in the comments that these two are listed as global variables. And what we mean by that is that they are accessible throughout all functions in that we have within this program. If we were to, for example, create another variable within the body of the main function, let's say we just write it down here, right? Which we do have this here this char variable. That variable would only be accessible or visible to the code that's ran in here within the main function. If we had another function below the main, then that other function wouldn't have access to our char variable. Whereas the gvar variable is inside the main function and any other subsequent functions we may choose to create. Okay. So speaking of our char function, so we've set the data type as char, so we know it's a character, and then we name it ch, and we store the capitalized A value. That we know is a local variable. So next we have here the following lines, which actually print out the values of those variables. The value of gvar1, and then this will print out, as we were discussing, 0. Value of gvar2, that's going to print 2, and then the character in ch. Okay. Now next here we are initializing two variables on the same line. Because they both share the data type, we don't need to declare that data type twice. We can save ourselves that step. And we are implicitly initializing sum and then explicitly initializing number. So sum, as far as all goes, is set to 0, and then number is set to 3. And in here, we are using sum to store the result of a calculation, as we had also discussed. So we have here the number variable, which is, if we recall, is 3, and then we're adding 5. So if my math is correct, that will actually output on the following line to 8. Okay? So think of variables as sort of like the working memory to keep track of certain values. We can just refer to them by their name. So it's quite handy, and you'll be doing a lot of creations of functions throughout the building of your programs. We have to make sure that whenever we create a variable, we give it a meaningful name. So it has to be a name that is easy to understand the purpose of that variable, not only to other programmers, but also to yourself later on down the road when you need to understand your own code and remember what you were doing, basically. Let's have a look now at another example where we combine the use of variables and constants. So in here, we have a program that calculates the circumference and the area of a circle, right? So we start with our preprocessors, then we have the namespace declaration, and then we go on to declare a constant. So we have here const double pi, and we know it's a constant because we're using the keyword const. Then we have the data type, so it's going to be a double, and then the name of the constant, which is pi. And lastly, we assign a value. So this is going to be handy because we can refer to pi anytime we want during the execution of our program, and rather than having to enter 3.14, etc. Another thing to note is that this is on a global scope, right? So as we were talking about global variables, this variable will be accessible in the main function and also any other functions throughout our program. So let's see here, we start the main function by defining 3 doubles. So we define area, we define circuit, and we define the radius. Now all of them, the area and the circuit are set to 0 because we don't set a value explicitly, and the radius is set to 1.5, right? We define the area as pi times the radius, which is 1.5, times the radius, again 1.5. And then the circuit, we define it as 2 times pi times radius. So you will get different results for both, obviously, because we have the different calculations. But then we have the printout, which will say to evaluate a circle, and then radius will print out just the radius, which will be 1.5. Circumference will print out the circuit variable, so the result of this calculation here. And then area will print out the result of the first calculation that we wrote. And that's it for this sample program. So we've reached the end of our session. And at this point, we've covered the fundamental types, we've covered constants, we've covered keywords, we've covered variables. And as you'll see, the rest of the material builds on heavily on these concepts. So it's definitely worth making sure that you've got a good understanding of them. If you do need additional assistance, you can always feel free to reach out to us on the platform. And as I have mentioned earlier, we can arrange personal tutoring to look at some of these concepts and get you up to speed. For the next sessions, they will be very hands-on, so we will go straight into the editor, so make sure to have it ready. Hi guys, welcome back. This is session 3 of our introduction to the C++ programming language. So as you can see from the start, we're going straight into the development environment, which in our case is Visual Studio 2019. I've got my solution here set up, and then within the solution, you can basically add projects. And for example, we've got here program 1, and then within program 1, you can add your source file, which is where we'll be writing our code. So you can go into new item, C++ file and then click add. So we'll only need one for now. And in here, we've got the actual text editor. So what I'll be doing is breaking down the code and making sure that you understand it. We'll run it to make sure that it works. And this is going to be the format for the remainder of the sessions going forward. It's going to be very hands-on and very practical. So let's get started then. You can see here from the comment at the beginning of the program, something that you definitely want to get in the habit of doing. It's quite handy. This program is going to just print out a message on the screen. Let's go ahead and run it, see if that works. And there you go, getting world of C++. And this is how we can write a comment, just the 2 forward slashes. This is what we call a single line comment. If you go on to the second line, that's not going to work any longer. You can see the highlighting is different. If you want to make it multiple line, you can go ahead and just start like that. And then when you want to end it, just do that. And then we're getting back to regular text. But anyways, let's get going and let's examine the rest of the lines. We've got here a include statement. So we're using the preprocessor of IOStream. That's the name of the module. And we're going to be needing this for the outputting of the text. Next, we look at using the namespace declaration. So this tells the compiler which dictionary we're using, which sets of words we're going to be using, of unique words we're going to be using throughout the program. If you get rid of this, for example, then NL will stop working, cout will stop working. So it's really important that you don't forget to put that in. And finally, we get to our main function of the program where everything is going to run. We've got here cout, which is the cout object, which basically starts that stream out to the console. And then we can add information to it. So with the insertion operator, we can add information such as a string, which is world of C++. Then we've got an NL in here, which is to end that line. So it acts like a line break. Okay? And everything is explained throughout by the comments that we've got on each line. So this is something that you can add when you do your own code to remember what each line does down the line, especially if you're doing something really complex. Later on, you can actually write a comment next to your code, and then that way someone else can look at it and understand. Okay. And then finally, we return 0 to basically communicate that the program has run successfully. This is something that we need to have in there. So let's have a look here. We can actually change this code to something else. We can change this string to the world. And there you go. So that's how that's how you can prove that the world of C++ text is actually coming from here. And that's something that I encourage you to do. There's nothing wrong with making changes to the code and trying things out yourself just to see how the program will respond. And that's a good way to learn. Just try to mess with the code yourself. Try different things. For example, we can add an extra line break in here before we get to the string. Change the code and really make it your own to try and see if you can learn things, learn how things work by interacting with it. So don't just read it. And that's it for program 1. This is program 2 of session 3. And what we're looking at here is a program to swap two numbers by using a third variable. Starting off in the beginning here, we don't have anything new going on. It's just really the preprocessor and then the namespace declaration. And we head off to our main function. So we're declaring those 3 variable placeholders, which will be A, B, and C, and they'll all be integers. At this point, they're all set to 0 by default. And what we'll want to do is actually store values in them or initialize them explicitly with the values that we've chosen. So A will equal 10 and B will equal 20. We actually go ahead and print that off. So you should see the value of A is 10 and then the value of B is 20. Let's run that and see how that looks like. And there you go, as we expected. Now the goal here really is to swap these two, right? So it
Thanks for watching. Feel free to add your questions as comments down below.
should print value of A is 20 and then the value of B is 10, okay? So first thing you might think of is just doing something like A equals B, right? And then B equals A. The problem with that is that at this stage, we would set A to 20. And then when you go ahead on the second line and copy the value of A, the value of A will be 20, right? So then B will end up being 20 as well. So to get around that, what we can do is use a third variable, which is C. So we can say C is equal to A, okay? And then you can do A is equal to, let me see here, A is equal to B, right? That's normal. Then when you get to B, rather than taking that value from A, right, which at this point will be 20, you can take it from C, which stores the original value of A, okay? So you can just do that. And if we run this, hopefully it should have the intended effect now. And there you go. So the value of A is 20 and the value of B is 10. So we've actually used C as a halfway point, essentially. And that's it for program number 2. This next program is going to show us how we can perform a sum calculation, but also, and I think crucially, how we can actually take input from the user into the console log and actually go on to store that within the program. So starting in the beginning, we have just our preprocessor and then our namespace declaration, so nothing new. And we go straight into our main function. We're defining two variables to store the input from the user. So they're both going to be storing an integer, so first and second, and then a sum variable, which again is going to be storing an integer. So then we go on to print out the command or the instruction for the user, letting them know what it is that they're going to be entering. So the first value of the first number. And then this is what we haven't seen so far up until now, which is the cin object. And what this does is it starts a stream of information from the console log. But rather than actually outputting the stream, we're actually going to be receiving information from the user. So it's the opposite, in a way, of cout. Next, you'll see these two arrows facing to the right, and they're there facing in a direction for a purpose. This is actually the extraction operator. So it performs the opposite job of the insertion operator, and it reads information that gets entered by that user, okay? So then we have the variable in which we're storing that information that gets entered by the user. So the user enters a number and it gets stored into the first variable at this stage, okay? So once that's done, the compiler moves on and we've got then the second message, which is enter the value of second number. And again, we follow the same pattern. We're using cin and then storing information that we gather into the second variable. Okay. Now to do the actual arithmetic operation or the sum at this in this example, we are just doing first plus second. So very, very simple. That should be pretty straightforward. In terms of the result itself, we are storing it in this third sum variable. Now, you wouldn't necessarily need to store it in a third variable. You could also do, for example, first plus second, and that will work just fine. So let's run it. Okay, so we're getting asked here for the first number. Let's see, okay, let's see 2, and then the second one is 2, and that is 5. Oh, no, it's 4. So that's it then running fine. As you can see, just as we expected. We could change this to sum just to prove to you that we can actually use that third variable. Let's see, two, two. There you go. What if we wanted to try another calculation? Let's see. To say 50 plus 50. Okay, and there you go. So any number that you or the user enters is going to be added up within our program. And the following sessions will show you how you can build on that and to build more complex programs. Because the user input is quite a huge part of the user experience, as you can imagine. So it's really important. And now we've got two polar aspects of that. So the C out for the output of data into the console, and then the C in for the input of data. So that's it. Welcome back, guys. So with this program, we're going to be taking in a temperature in Fahrenheit and converting it to Celsius. So in the beginning, we should be thinking, what pieces of data am I going to need to store, right? And with that line of thought, you should come up with the temperature, right? So you have two temperatures. So we're looking at the F temperature and then the C temperature here, which are the two variables that we've chosen. And they're both going to be floats, as we're going to be dealing with decimal points. So that's going to be our Fahrenheit, and that's going to be our Celsius. Then we've got our output to the console. So just to let the user know what we're asking for. And then we're going to be using the cin object, which we previously talked about, and then the extraction operator to store that input into the ftemp variable. So this is how we're going to be collecting our Fahrenheit temperature. Then we have to convert it to Celsius, right? Now, quick Google search will get you the formula, and then all you need to do is just plug in the variables, which in this case would be ftemp. So we're subtracting 32, as shown by the parentheses, and then we're multiplying times 5 divided by 9, okay? So let's go ahead and see. The next line would just be about printing out the result. Let's just run that and see how that works. So one I can definitely tell you I remember and I have fully memorized in terms of Fahrenheit Celsius conversions is 32. So 32 should give us 0 in Celsius. And there we go. So you can go in and you can try any value you like. And it should convert to Celsius. And there you have it. So we are now at the last program of session 3. And for this one, we're going to be reversing a number of a given year with 4 digits. So let's jump right in. And we have here our main function, and we start with a couple of variables being paired. Now, all of these variables are going to be unsigned ints because we are only looking at positive values. So we're not going to be looking at any negative values, and we're limiting the program just to those positive values so that we don't get any negative numbers. So starting out, we print out a message for the user. So enter the year, and then with cin, we actually store the year that they enter into the y variable. So y will be for the year, as I mentioned. And let's just take, for example, the year 2020, a great year. And I'll take you through it using 2020 as an example. First digit, we would divide y by 1000. So 2020 by 1000. That gets us our first digit. And then we want to carry over the result of 2020 modulus 1000, which is going to get us the remainder, or in this case, 20. For the second digit, we would divide that result that we carry over by 100, which would get us 0, and then 20 modulus 100, which would still be 20. And for our third digit, we would go ahead and do 20 divided by 10. That would get us 2. And then we would update the result here doing 20 modulus 10, which would get us a remainder of 0. And for the fourth digit, we just do the latest result by 1. We would do 0 divided by 1, and that gets us the fourth digit. And we go on in that last line to just print out the, first of all, we obviously write the message the reverse number is, and then we just print them out in reverse order. So digit 4, digit 3, digit 2, and digit 1. So let's see that in action. We're getting 0, 2, 0, 2 as expected. Let's try another year. And there you go. Welcome guys to session 4. So we're going to be reviewing some examples of if statements, if else, and also nested ifs. So with this first one, we're going to be finding out if a given number is odd or even. We start here in the beginning and we have a preprocessor stream. We're dealing with output, namespace declaration, and we go straight into our main function. So we define here an integer variable. So that's to store the number that we'll be asking the user. And then we're going to a message printout. So to let the user know that we're going to need a number. And then we're using cin to store that number in the n variable. Now this is where we get our first if state. So basically what we're doing here is we have defined two scenarios. The first one is scenario 1, where the number is even, or scenario 2, where the number is odd. Okay? And this is based on two conditions. So the first one is this one. So the if statement carries the main condition. If whatever is in here calculates or computes to true, then the first scenario will be played out. Okay? And then if this first scenario does not play out, so if this ends up being false, then the second scenario is going to play out, essentially. So this is a very specific condition, and then the second condition acts almost like a catch-all type of scenario where it's going to catch everything else that comes and that is not true in the first instance. So looking at this here, we are actually using the modulus function. So n modulus 2, just to see if when we divide n by 2, are we going to have a remainder? If the remainder is 0, meaning it divides evenly, at that point, that means that the number is even. So we go into that first scenario. But if the remainder is anything but 0, then we know that that number is actually odd. So we go into the second scenario. And you can actually have as many lines as you want here if you wanted to. This at this point just starts from this bit here and just executes whatever is left until the next statement ends. But you could, in theory, you could add some brackets here and you could execute multiple statements within that if. So you could say, yes, it is even. Right. So here we're actually printing out 2 lines of text, and this would all happen if that first condition is true. The same can be done for the second condition, or the second scenario. I think is probably the best way to look at it. You could add whatever you wanted here, really. So you're not just limited to doing one statement. You can actually do multiple statements if you make use of the brackets. Let's go back to that original code and let's just run it so you can see how that works. There we we are. So into the number, let's go for 2. So you know that's even. Number is even. Let's try again. Let's go.
If you have enjoyed watching this video, please subscribe to our YouTube channel. Thank you.
For 0. That's even again. Yeah. Let's try an odd number just to test out that other scenario. Yeah, there we go. Now, just to show you that, use the brackets. Let me put those back in. And let's go for an even number. See, so it's actually printed out both statements. I didn't put an end line, so as you can see, just added it onto it. But there it is. So that's your if statement. So for this next program, we're going to be asking the user to enter a set of numbers. And then the program will be comparing these in the background to determine the greatest one amongst the ones that are entered. So it's going to evaluate that answer depending on the values that are entered on the spot, right? So let's deep dive into it. And we start with our preprocessor or our include statement, and that's going to be the IOStream module. So we're going to need this for 2 reasons. One, to output messages to the console log, and then also to read data that is entered from the user. So we're extracting that data from the console. The next one is going to be our namespace declaration. So again, that's really important just to let the compiler know which set of unique words we're going to be using when we write our program, just so that our compiler understands where to look and basically to understand the dictionary that we'll be using in our code. So then we have our main function. And as I mentioned previously, this is important because you could have many functions in your program, and this is the first one that will get ran by the compiler. So in this case, we're not going to be adding any further functions, but everything will go inside. Okay, but it's basically the function that the compiler will go to first as a starting point. So when we're thinking about this scenario of we're asking the user to enter some numbers and then we compare them later, we start by thinking about, okay, where are we going to store that data? And we can actually define some variables for that. So this is what we have here. We have 4 integer variables, A, B, C. So A, B, C to store those numbers, and then max to store the greatest number. So we're storing the result of that comparison within the max variable. Okay, so then we have our first message to the user by using the cout object in here, and then the insertion operator. So that basically takes that data or information and it adds it to that cout object for it to be displayed in the console. Then we have our cin object to read in that data that the user enters, and our extraction operator to save that data within the A variable. So in here, these 2 lines, what we are doing is outputting that message to the user, hey, can you enter this? And then once they enter that data, we store it in a specific variable so we can refer to it later, or we can use it in a whole variety of ways. We repeat that process for the second number. We store that in B, and then for the third number, and we store that in C. So far, we've defined the variables that we're going to use to store the information that the user enters. Then we ask for that information and we store that information. So we've got all that data up until this point, and we can start processing it and actually making that comparison. And one way to do that, as you may have guessed, is using if statements. So we've got our first if statement here, and you start with if, and then you've got your condition that you're evaluating within a set of parentheses, right? So we have here A is higher than B, and if that's the case, that's going to be true. If not, that's going to be false. So you will get one of two outcomes there, right? If that's true, then the first statement will get executed, and max will be set to the value of A. If that is not true, then you go on to the next statement, which is just an else statement. So else has no criteria attached to it, meaning that if for whatever reason this first scenario or criteria doesn't turn out to be true, doesn't get executed, we automatically go on to this else statement, and this will for sure get executed in the event that that first scenario doesn't take place. Okay, so with these 4 lines here, we are essentially determining which of the two is higher between A and B, right? So we've got that comparison done with, and we can move on to the next one, so which is dealing with C. So this if statement here just compares C to the current max. That could be A, that could be B, but it really doesn't matter up until this point. We just know that that's the max, and that's really the number to beat. So if C can beat that number or is higher than that number, then you get a new max number assigned. So max would take the value of C, right? So with these two if statements, we've gone ahead and we've analyzed those numbers, and we've determined which is the highest one of them all, and or the greatest one of them all, and it could be either A, B, or C. Now, one thing to note is that first if statement will always get evaluated, as well as this second if statement. The else part will only happen or will only get evaluated if this first scenario doesn't happen because it turns out to be false. So it will basically check, okay, is this true? Okay, if that's the case, then do that first statement, otherwise do that second statement. But then when you get to that second if statement, it will definitely evaluate this, okay? And it will say, okay, if this is true, then set max to C. Otherwise, if that's not true, this will not get evaluated, and it will just do nothing because there's no further else statements that are following it. Another thing you could also think about when looking at this is the way that you write your if statement. So you could also add in some brackets, okay? And what this will allow you to do is, I mean, at first glance, if you just add the brackets, it's not going to make any difference whatsoever. That code will run and you get the same exact output regardless. But what these brackets allow you to do, besides maybe visualizing it a bit better what's happening here, is you can add in a second or as many lines as you want. So for example, we could add a message that says A is greater than B. And rather than just having one statement executed, if this is true, you could have multiple statements within the body of that scenario. Essentially, you could do the same thing with else, and it's something that you might want to try if the syntax without the brackets seems too simplistic or it might be a bit confusing. Just picture those invisible brackets being there, or if you want, you can actually add them in yourself. It won't make a difference to your code execution. And then the last thing we're doing in this program is we're actually outputting the result, right? Because there's no point really in doing that comparison if the user cannot see what's happening or if they cannot get that result output on the screen. So we're just outputting a message with, again, cout, and this message will say the greater number is, and then print out the value of max. So let's see that in action here. Okay, here we go. So let's say we do 5, and then we can do 15, and 10. There you go. The greater number is 15. And that's been calculated using the if statements that we've been covering during session 4. That's it for program 2, guys. Now we've seen a few examples of how we can use if statements within a program to build out different scenarios, different decision trees, and you can see just about how handy and extremely useful it can be if you want to implement business logic or build out a series of events that are complex in the way that they get triggered. And you go from having a basic program that does the same thing all the time, having a program that reacts to a variety of different circumstances. Okay. And my hope with this next program is that you can start to get more comfortable writing your own code and specifically taking advantage of this new tool that you have available, which is if statements, right? So follow along, pause if you need to take your time, but try and see if you can come up with your own solution. Okay, you can compare it with mine as we go along, line by line, or as you wish. Don't worry too much if you don't get it right the first time, or if you get stuck with syntactical errors. Just try to write as much of it as you can, and we'll both get there in the end. Okay. So this scenario that I'm going to give you is we have a user that enters a given mark. So let's say a mark for school assignment, anything of the sort. And the program is going to output a grade for that given mark based on a grading criteria. Okay. And this can be anything you want it to be, such as, for example, if they get 85 or higher, that's A plus, 80 or higher, A, 75 or higher, B, 70 or higher, C, and then so on and so forth until you get to F, right? So thinking about that from the beginning, right? The first thing that's obvious is we're going to be dealing with both input and output. So for that, we're going to need to include the IOStream module, okay? That's going to help us with that input output. Then we're going to be using our standard namespace. This is probably the bit that you might find yourself forgetting because it's not that straightforward in terms of the flow of the writing, but it's really important. It's just to let the compiler know these are this set of keywords that we're going to be using to define our program. So it just it just helps out the compiler in understanding our code. Then we're going to need to run at least one function, right? Which is the main function. That's going to return 0 upon successful completion, and that is going to be returned the type of int, of course. So we've declared all that, and we're set to go in writing the specifics of our program. So next, let's think about the data that we're interacting with and how we can store that data. So we're going to be asking for the user to enter marks. So we can define an integer variable called marks. And I guess we'll make that singular, so singular mark. And then we output a message to let the user know. So please enter a mark number. Okay. And then we need to store that information into the mark variable. So we use the cin object. This is when we get to the more interesting bit where we actually analyze that mark. So if mark is higher or equal to 85, then we output a message saying the grade is A plus. Okay. Otherwise, or if else, the mark is equal to or higher than 80, then a message the grade is A. Okay. And then otherwise, if mark is higher or equal to 75, output grade is B. And that's getting a bit boring, so let's just copy paste that through. Okay, so we can get there a bit faster. that's D. And then for the last one, we don't really need to check anything. It's just if we haven't
Thanks for watching. Please like and share this video.
got a grade up to this point, then we just assume whatever is left is going to be F. Okay, so we don't really need to add a condition here. It's just going to be else. Now, I specifically mentioned that I was copying and pasting, and actually that's a terrible idea. I'll tell you just about why that is in a moment. But first, let's run our code to see that it works. Okay. Let's see we did way good on this one. That person got an A plus. There we go. Let's try and see what happens when we enter 73. Let's see, right? Because it got to B and this was false. And then the next one was C. And it was higher than 70. So that's why we got left with C. Now, whenever you see yourself copying and pasting, that's generally a bad sign or a sign that you're writing code which could be much more effective. And I'll tell you just about why. So let's say we wanted to change this message, right? Not the grade itself, but the message. We would have to go in here and type the grade given, let's say we're making this change. And we're wasting time, right? It's inefficient code. What if we make a spelling mistake here, right? And then you have it different across, right? So one way we can avoid this is the following. Let me just show you. We take that message, we make it into just one line because we're always going to be outputting that message. That's the commonality. So take out the commonality between all those scenarios. Okay, and then we can just output the grade. And the grade is the only thing that will change. Now we can define that up here. It's a string. And then in here, rather than outputting the message, we can just set the grade every time. So A plus. So we're not outputting anything. We're just defining that grade depending on the mark. And this is much better, as you can see now, because we're repeating ourselves much less now. And if we needed to make a change to the message, we need to just do it in one place. Okay, so that's a bit better and definitely something that you need to bear in mind when writing your code. How can we isolate the commonality so that you don't end up repeating yourself as much within your code? And again, let's see, 73, exactly the same result, just with a different message, all within one line in here. So that's it for program number 3. For our last program within session 4, we're going to be looking at how we can actually encapsulate if statements within other if statements and how that affects the execution of the code. So this program will be taking in numbers from the user and then outputting the smallest of them all, right? So starting from the top, we have our preprocessor. So we'll be using the IOStream module because we're dealing with input and output. Our namespace declaration to, again, let the compiler know what unique set of keywords we're going to be using to define our program. And then we go into our main function, which is going to run all of our code. Okay. So thinking about what sort of data we're going to interact with and how we can store that, we go on to declare our set of variables here. So they're all going to be integer A, B, C, and then min to store the smallest of the values. Then we instruct the user so we can print out a message using the cout object, and that basically starts a stream of data to be displayed onto the console. We use the insertion operator to add data to that stream, and then we add the string that reads enter the value of A. So that's a fancy way of saying we're just outputting a message out to the screen to communicate with the user, We then use the cin object to read that data, and then the extraction operator to input it or save it in the a variable. We repeat that process with the second number and then with the third number. And then finally, we get to our decision making. So we have really three main if statements, first one, second one, and the third. Let's break down the first one so that you can understand a bit of what's going on. And I'm gonna just add some brackets here just to, again, make it easier for you to visualize the body of that if statement. And hopefully that helps clear out any sort of confusion. Now, bear in mind the brackets will not change the behavior of that code. You'll still get the same result. But like I said, hope that it helps. So we've got an if statement within an if statement, and I'll show you how that can work. So this first condition will either get evaluated to true or false, that we know. And then just like any other if statements, if that is true, the body of the if statement will be executed. Now, that doesn't mean that min will be set to a straight away, but that does mean that the second if statement will get executed. And as part of that, this condition evaluated. So if this is true, the next thing the compiler will look at doing is seeing if this second condition is true. So is a less than c. If that's the case, then and only then will min be set to the value of a. Okay, so for min to be set to the value of a, it has to be lower than b, and it has to be lower than c. Okay, so let me just get rid of those brackets there. And that is essentially what is happening. Okay, so that it will run exactly the same with or without the brackets, but it's just for simplicity. As you can see here, we have less lines of code. The same thing happens with this if statement here. So if b is less than a, and then if b is less than c, only then will min equal b. And then it's the same thing for c. And finally, we just output the smaller number using the string here being sent to the cout object, and then we print out the min value, the final min value. So we can actually run that and see if that works. Let's input 599, see, and then we get 5. Okay, so that's working fine. Another way we can rewrite this, and it might be a bit simpler to understand, it might be suitable for a lot of situations, so it's good to be aware of, is you can do something like this. You can do if a is less than b and a is less than c, and min was a, right? And then you can do if the second one, if b is less than a and b is less than c, equals b. If c is less than a and c is less than b, min is equal to c. And as you can see, that's a bit more clear, and you can write that in just 3 lines of code. So that's another way to do it, which depending on the situation might be better for the intended program. So you really have to think of what's the most concise way to write the code, the most effective way. And that's really going to change depending on the requirements and depending on what you're doing. So that's our last program of session 4, and I'll see you in session 5. Hello and welcome, guys, to session 5 of our introduction to the C++ programming language. We're going to be building on that knowledge that you acquired looking at if statements and trying to actually use something that's quite similar. It's called switch cases. Now, this comes quite in handy whenever you need to make decisions or run logic based on the evaluation of a single variable. And the best example I can sort of give you is looking back at that program that we wrote, took in a numerical mark and then gave you a grade based on that mark, right? So in that case, we have the singular variable that's controlling all the different scenarios that can come afterwards. And in that scenario, we end up with lots of if statements, right? If you recall, because you have an if statement, if it's an A, if it's a B, and so on. So you end up with if this to that, if this to that, if this to that. And it becomes a bit convoluted and unnecessary when really you only have one variable that you're evaluating. So rather than evaluating that one variable tons of times, we can use switch cases to evaluate it once, and depending on the result of that evaluation or the value of that variable, then you direct it to a number of different outcomes. Okay, so we'll try to do that because it's the best way to understand it is through an actual real life example. So we're going to build a program that takes in a character, and then depending on the actual character entered, it determines if it's a value or not. Okay, so first things first, we have to start thinking about, which preprocessors do we need to use, which modules do we need to include, and that would be the IO stream. So include stream. That's because we're dealing with input and output. So the input coming in from the user, and then the output coming out in the as form of a console message. Okay, so next thing is the namespace. Standard, and we get into our main function as always. Okay, so what sort of variables would we need? What sort of data are we interacting with? And in that case, we need a character. So character entered, that's one. And we could also have another one to store the result of our analysis, right? So is bow. So that's going to be true. If we're going to set that to true if we determine that the character is a vowel, otherwise we'll set that to false. And next we can output a message using the cout object to request that the user enters a character. Please enter a character. Okay. And then we're going to read that data using the cin object and store it in the character entered variable that we previously created. Now we get into the actual switch case statement. My spelling there. So this is when we actually get to make that decision. And we're going to be doing that using a switch case statement. I would be confident that by this point, you should be able to do that with an if statement. But hopefully this will show you another way to do it that might be more efficient in some cases, such as this. So we go in here and we start with switch. And we're going to want to enter here the condition, or basically the variable that we are evaluating. We're going variable for which we care about the value in terms of determining which scenario plays out. So that would be character entered, right? Because depending on which character it is, we evaluate if it's a vowel or not. Then we have two brackets. These two brackets will encapsulate the body of that switch case statement, right? So we're switching cases depending on this variable. I guess that's another way to look at it. And then now we need to start thinking of our cases. So we could literally write out a case for every single character in the alphabet, but that would take ages. And it might be more simple to just write out the cases for vowels. A is B, C, sorry, my mind just carried off there. So is Oh. Okay. And then finally, we can have a default case.
Thanks for watching. Feel free to add your questions as comments down below.
And that will basically take place if none of these get selected. So we have two types of cases. We have cases for vowels and then for non-vowels. Okay. And then what we can do is we can actually write out the code that gets executed for each case. So if it's A, its vowel is set to true. If it's B, its vowel is set to true. Okay. And so on. Okay. Let's see here. True. And then we have this here. True. And then for the final one is vowel is set to false. Now, two things with this. First one is if we actually run this code, we will get an error because this here is a string. We have the quotation, double quotation marks. So this character will not equal a string. We need to be very careful with that. That's why we need to use single quote marks. Just make sure to change that. Anybody who spotted that early on, great job. And the second thing with switch case statements is we need break clauses. If we keep this as is, and for example, the user enters the character U, this code will get run, and also this code, because you have sort of like a cascading effect. The switch statement will look for the first case that matches, and if there's no breaks clause, it will keep on running the code below it. So it's really, really important that when you're thinking about creating a switch case statement, that you're mindful about including break clauses. So we would need to put in here break. Okay. You can think of it sort of like a waterfall. One way to look at it. So now, if this character, for example, is A, it will get to the case A, it will look at what statements it has, and then it will run that statement, but then it will end at that statement. It will not keep going. Okay, so let's see what else is left. Next, we need to output the message. So for that, we can use an if statement. So if is vowel is true, then we need to see out is a vowel. Okay. Else see out character is not a vowel. Oh. Now, another way we could write this is, of course, we could include the brackets for the if statements to encapsulate the body. And you can feel free to do that. That helps you visualize the code and understand it a bit better. But it's not going to make a difference at all. So I'm going to get rid of that for simplicity. The other thing is, as well, within the if condition, because is vowel is literally a Boolean data type, we can actually get rid of this here, because by definition, if this condition within the if statement evaluates to true, then it's going to run the rest. If it evaluates to false, then it won't run the rest, and it'll go on to the else line. So by us adding this here, it really is redundant, and it's not going to make a difference to the code. You can leave it there if it helps you visualize the code, as I mentioned, and then later on you can start being a bit more concise with it. But for now, I'm going to get rid of that. And I'm going to run the code just to make sure it's working. Okay, so let's try J, which is not a vowel, in case you're wondering. Let's try A. Now, just to prove to you the concept of cascading within switch statements, I'm going to show you what that looks like visually. So I'm going to output a message here every time A, the case of for A gets called. And I'm going to output a message every time the case for I gets called. And I'm going to get rid of those break statements. So I'm going to get rid of the one for A. Okay, so if we run that, and then we enter A, that's what happens. We actually get A printed out, and we get I printed out, just as I had put it in here. So we know that the compiler went first to the case for A, right? Because it was an A that we entered. It set isVal true, but because we did not have that break statement, it cascaded on to the next case below it, which was I. And it really was, I mean, in this case, it was intentional, but you can see how if you forget to include the breaks, it can become unintentional behavior and it can cause bugs in your program. So hoping that this was helpful in understanding switch case statements. If you do feel like you need additional assistance, we can provide it. Just check out on the platform. We have plans for private tutoring available, not only for C++, but for other languages. So if you do feel like you are stuck and you need some help just moving forward and just getting you going, please get in touch. We'll be more than happy to arrange that for you. Okay, so for our next program, we're going to be asking the user to provide 2 digits as well as a arithmetic operator. And then we'll go on to proceed in performing the calculation based on the operator chosen and displaying the result. And we're going to be using a switch case statement that we've covered now before. So let's get into it. So from the beginning, we can think of our preprocessors and which ones we'll need. The obvious one that I can think of so far is the IO stream, because we're dealing with input and output. So let's go ahead and declare that loads stream and then namespace patient, and then we go into our main function. So okay, so nothing new so far. Everything's up until this point. And then we start thinking about which variables we need, right? How are we going to store our data? What data are we even interacting with? And I guess you could say we have those integers, so say x for the first one, y for the second one, and then we'll store the result of the calculation separately. Then we have a character for the operator entered, okay? And then we can start thinking about directing the users, telling them what they need to do and do. So it's to cout object to print out the screen, and then please enter the first number. Okay. Then we use the cin object to read that data. Notice the direction of the arrows, and that's the extraction operator, which is saving that data in the x variable. We repeat the process again for the second number. Oops. And that's going to store that on the y. And then finally, for the operator, so please enter a operator example. Adding. I need to put in some skip sequences there. That out. And then I need to change this here. Let's throw that there. Okay, now we get to the switch statement where we can actually perform the calculation. So operator entered. And this is a great use case for switch case kind of structure, because the routing or the way that we're selecting the case that we're gonna execute depends solely on one condition on one variable, and that's really when it's great to use a switch. Because if you were to do an if statement, you would have to repeat yourself. You would have each time you go if this, if that, and it would all be the same variable that it's looking at. So it's a bit redundant, and it's a bit cleaner to do it in a switch if it's this type of scenario. So let's define our cases. So the first one is going to be plus addition. Next one is subtraction. Next one is multiplication, and finally division. Actually, well, I guess you could call it one more as well. The default. We're going to have a default case in case that they don't select anything valid. So we would output a message invalid operator entered. So let's define our cases. It's plus, it's an addition. It's minus, the result is subtraction. It's multiplication, so it is addition, of course. And if you guessed it, division. This indenting needs to be improved. There we go, a little bit better. Okay. Now, you might have noticed already, but something that is entirely crucial, otherwise you'll be wondering what's going on with your switch statements, is having break clauses. So it's really important to add them in. I've explained this previously, but I will emphasize it. If you, for example, don't add a break clause to the addition case and the user enters addition, this code under this case will be executed, which is great, it's perfect, but it will then cascade down to the next case, and this code will be executed. It will stop here because there's a break clause, because otherwise, if that wasn't there, it would continue cascading downwards like a waterfall. That's really the best way that that works for me in terms of visualizing it and remembering it. So if you can think of that waterfall or that cascading concept, it will help you remember that you need to be adding in the breaks. Now, last thing we'll do is we will output the results. Okay. So let's test it out and just see that it works. 2 and 2 plus 4. Let's try another one. 5 multiply this time. 25. Let's try one where we don't enter a valid operator. Let's just enter 0. Now we get an error, and I'll tell you exactly why we get that error. Because if you recall back up to this point, we define or we declare the result variable, but we don't give it a value. And that can be problematic down here because we actually try to print out the value of this variable, but this variable is undefined. Therefore, you get an error. So you can see here using uninitialized memory result. Now, one way that we can get around that is, for example, doing a check here. So, for example, we can add a Boolean called valid operator. And let's set it to true, okay, by default. But then if this default case gets run and we know that it's an invalid operator, we can go in and say valid operator. Actually, let's put that valid operator chosen just to be more clear. Right. So we can flip that to false in case we don't have a valid operator, and then wrap this inside an if statement. So if valid operator chosen equals true, then publish the results. Okay. And again, as I mentioned, you don't need to do this, in terms of adding equals true if it's a Boolean, because by definition, it will either be true or false. You don't need to.
If you have enjoyed watching this video, please subscribe to our YouTube channel. Thank you.
Match it to something else, but it's up to you, whatever is easier to understand. Let's try that, and hopefully we've avoided the error now. So 1, 2, and then some random right there. Then, as you can see, this ran successfully. And this bit here, the problematic bit at the end there, it was not executed, which means we avoided that error in the end, and our program is a bit more robust. Hello and welcome, guys, to session 6. So we're going to be looking at loops in general throughout session 6. And for this program in particular, we're going to be focusing on the for loop. Okay, so trying to understand how it is that it works. And loops in general are a very important part of programming because they allow us to give a singular instruction to the program and then having the program repeat that instruction as many times as we want it to. And then throughout, you can hold variables within that loop that hold, for example, the updated sum of a count as such. So I think the best way to understand loops is to actually look at a real example. So for this, we're going to look at a program that asks the user to enter a date. That date has to be starting from January 2001. And then based on that date, it calculates the day of the week, and then it outputs it onto the screen. Okay, so let's dive deep and look into it. We're starting with our preprocessor, which is the IO stream, because again, we're dealing with that input-output. Then we have our namespace declaration. We're going to be using the standard namespace. And then we have our main function. Okay, so good so far. This is all contained within our main function. Okay, and the first thing we want to do is collect that data from the user. So let's create some variables to do that. We have our day, month, year. That's going to be integer. And then we are going to output our message to ask for that day value. And then we're going to store that using the cin object. And then the extraction operator, we're going to store that into the day variable. We then go on to ask for the month, and we ask for the year. So far, so good. You should be able to remember this bit about collecting data. We've done it a few times now. The interesting bit will come down here below when we start looking at loops for the first time. So we're going to be looping through the given year's months passed so far, and then turn those into days. And I'll show you how we can do that. So we need a variable to keep track of that day count. So we're going to add the number of days as we go through that year. Okay. So let's say we have here the day count variable, we set that to 0. And then we have our for loop. Now, the for loop is defined by the for keyword. We then have the parameters of that for loop. You can think of it as the setting. So, how often, how that loop is supposed to go and when it's supposed to stop. Then we have the body of the for loop, which is encapsulated within these brackets. Now, going back to kind of the setup of the loop itself, or the settings, you can think of them as the parameters of the for loop. The benefit of the for loop is that all of the settings for it, or the instruction set in terms of how many times that's going to loop and such, the variable that we need to actually accomplish the looping, all of that is defined within these parentheses here, right? So for other loops, you might have to define the variable that keeps track of which iteration we are on, right? You might define this outside, but for the for loop, the nice thing is that you can actually define this inside. So we keep track of which lap we're on. You can think of it that way, or which iteration we're on. And that's going to start with 1, right? So we define this variable within the for loop. That means we can use it to keep track of where we're at within the loop. And then we're going to loop until I is less than the month entered. Okay. So, and then the other thing that we need to do here is clarify what's going to happen to the I value during after each loop, right? So we have three elements. We define that initial tracker variable. Then we define an end condition. So when that loop is going to stop. And then we specify how we're going to modify that value that we're using to keep track of the loop. Because if we don't specify this, I will never change unless we explicitly change it within the body of the for loop. So this is going to happen automatically because otherwise, if we did not increase I, it would stay at 1 and it would never reach that end condition and it would keep on looping forever. And we don't want a never-ending loop in this scenario. Okay. So next, we go ahead and add days to the day count depending on which month we're looking at and whether or not it's, for example, a leap year. So if we have I representing a month that has 31 days, right? Then we go on and add 31 days, otherwise 28 days, otherwise 29 days, and lastly 30 days. And this all happens based on the if statements, essentially. So we have here the if statement and then 3 else ifs. So one of them is bound to happen, essentially. Okay. So we would look at January, for example. January would fall under those months with 31 days and at 31 to the day count. Then the following month, we would look at it and see if it's a leap year, because actually we have here, if I equals 2, then it really depends on whether or not it's divisible by 4 the year. And then we determine if it's a leap year. And if it's a leap year, we add 29 days. Otherwise, we add 28 days to the count so far. So as you can see, we are basically looping through the months of the year, right? And depending on the year that was entered, we're calculating if it's a leap year, we're calculating how many days per month, and we're translating those months into days because we're going to need that later for our calculation. So that's the first for loop. Don't worry too much if you know all the aspects of that didn't sit you know quite well right away. We have to look at some more examples and then it'll start to come into a clear picture for you. Okay, but just get the idea that we're basically repeating this code that is encapsulated within the body of the for loop. We're repeating this code as many times as we tell the program to. And how do we tell the program? Right here. Another note here about the modifier here. Once we've run through the body of the for loop once, this is when we have this incrementation, right? So this bit, you can think of it as being right below here, okay? Now, moving on. Next, we have to loop through the years and count how many leap years we have. So we created a variable to keep track of the count of the leap years. That's set to 0, of course, as a starting point. And then, as I mentioned to you, we have the for keyword. So we know we have a for loop here. We can think of them as the settings or the parameters of the for loop, right? The instruction set. And then we have the body of the for loop. So it's actually going to be repeated, okay? So for the year iterator, we're starting at 2001. So that's the limitation that we set on this program. Calculating the day of the week can get a bit tricky if you go past that, really, in terms of older dates. So to keep things nice and simple, we've set this limitation to 2001. So we're starting with 2001 and counting those leap years. And then notice how instead of calling this tracker variable I, so for example, in here, we had it named as I, and that in itself is something that you'll see quite often in programs. Programmers will often give the iterator variable It's really simple name. You can always give it something a bit more meaningful. So in this case, we've named it the year iterator. So it would start at 2001. The loop will stop once the year iterator is goes above year. So if this condition is false, right, that's when the loop will stop. So as soon as it goes over the year. And then the next thing is the modifier. So the year iterator will increase by 1. This plus plus symbol, it basically takes the current value and then it adds 1, right? So after each iteration, this will happen, okay? So next we have the body of the for loop, and we just have an if statement. So it's quite simple. We look at the year iterator, its current value. So in the beginning, it would be 2001. Then we would see if there's a remainder or if it's divisible by 4, right? And if it's divisible by 4, we add a leap year to the leap year count. So you could write it like this. You could also do something a bit more simple. You could just do this, for example, and that would add 1. So just as we had it here for the iterator, for the leap year count, we could also do it this way. It would be exactly the same. But just to show you what's happening, I'm going to write it like this. It's a bit more visual, I suppose. So that's how we look at the for loops. And then we simply look at the year counts and we subtract the year 2000 minus 1 for the current one. Okay, so we get the number of years that have gone by so far. And then we have to calculate the total day count. So how many days in total since the year 2001? And for that, we basically have 2 variables to keep track of it. We have the total day count and then the resulting day number. And I'll show you how that comes into play in a moment. But we're basically adding up days in the current month, day count from previously elapsed days in the year, leap year count, and then the year count times 365. And that in total is going to give us the total day count. Don't worry too much about the formula itself. We're mainly focusing on those for loops. So don't worry if you don't understand the formula right away. That's not really the focus here, but just to tell you how we're getting to the end result, okay? Also, nice to know that this is a multi-line comment. Otherwise, you would have to go in and do something like this. So it's quite repetitive, and it's with something like this, it's nicer to do a multi-line comment. You start here, and then you end here. So we're adding up our total day counts, and then we basically get the remainder when we divide by 7. And depending on that remainder, that's going to give us the day of the week, okay? And for that, we're using a switch statement. So we enter the resulting day number, and then we translate that using the switch statement. So if it's 0, that's going to be Sunday. If it's 1, it's going to be Monday, and so on and so forth. And that's it for this program. If it helps, you can always go through it one more time, read through the comments. And as I mentioned, if you want to sit down with someone and actually take things at your own pace, if you have any questions, make sure to sign up for our private tutoring on the platform. But now let's try and see if that works, if our calculations all add up. So let's run that program. And let's try 11th of November 2020. And that would be a Wednesday. And there you go. That's correct. You can try it on your own with different dates. Try experimenting with the code, playing with it. Something that you can do, it helps you visualize the loop. You can actually go in here and print out the value of I or of the tracker variable for the iteration. You can do something like this, so you're aware. And that way, every time it goes through and it prints out, you will get a reading of that value of I, so that you can understand how it's changing as the loop goes through. So in the very beginning, that's going to be 1. then it's going to be 2, then it's 3, until it reaches a point where it goes over the month, and then that gets canceled out. So that's the first loop. And it's quite handy to do this as well if you're not getting the result you expected and you want to do some troubleshooting.
Thanks for watching. Please like and share this video
to find out what's going on behind the scenes. So that's something that I would recommend. You can also play around with the initialization. So if you want to set this to 15 and see how that affects the outcome of your code. If you want to change the end condition, so if you want to do month plus 1, you will see that it ends up finishing 1 month later than entered. Okay, the other thing as well you can do here, so you can do I minus minus. So it's rather than incrementing the I variable, you can actually subtract 1 every time. That's something else that you can try on your own. And that's it for our first program looking at loops. Now that we've taken a look at the for loop, we can move on to analyzing the while loop. And for that, we're going to build a simple program that uses a while loop to loop through an iterative value. And depending on the value of that iteration, it's going to display a different color on the screen in terms of the text color. So it's going to cycle through. We're going to be able to see those values within each loop iteration. And then we're going to get a different color as well, just to visualize it as it goes through. So let's get started. We're going to need an include statement here for preprocessor, which is going to be strlib.h. Okay. And then we're going to need also input and output. So that's going to be string. So stdlib is necessary for actually changing the color of the text. So this is why we're including that here. So let's go on then, and the next bit will be the namespace declaration. And then we have our main function to run our code. Okay, so now the downside with a while loop is that you have to declare that that tracker variable that I told you about, the one that tracks the iteration, so where we are on the loop, okay? And you have to declare it outside of the while loop, so before the loop itself. So to some people, it can look simpler. I generally do prefer it, but it's more of a personal choice at this stage, really. So we have to declare it here. Let's say our I would be starting at 0. So that's going to track our iterations. And then here we declare our while loop. So the body of the while loop is as follows. We have the while keyword that is declaring that while loop. And then we have our condition within the parentheses, sort of like an if statement. So it's basically saying, well, this condition is true to the following. It's kind of like an if statement that just repeats itself, essentially. And you can think of it that way. So for this, we need to specify the condition in here. In this case, let's say I is less than 20, right? And then we can specify the block of code that we want repeated within the body. So you can see here why to some people it can make a bit more sense when you, when you read it, it flows a bit better, I suppose, than a for loop, in the sense that you define this separately. So this could come from any other source, any other bit in your code, really. And then you're just looping through it in here. So while this is true, then do that. I guess it's a bit similar to the if statement. So you can accomplish the same things with both the for loop and the while loop. The while loop will just essentially keep on going until you get to this point. You also have to worry about writing in an increment. So, for example, in this case, we're going to do I plus plus. So after each loop, at the end of it, it's going going to increment by 1. You could, I mean, in theory, you could put it in the beginning, right? Depending on what you want to accomplish, you could do that. But just to keep things simple, and I'm going to keep things, I guess, similar to that for loop that we looked at previously. So it's, you can just see the difference in the syntax and focus on that. I'm going to keep it at the end, right? Because when we were looking at the for loops, if you remember, the increment happens towards the end, so at the end of that for loop. And now we can start thinking about what actually happens in here. So let's say that if I is divisible by 2, so if it's an even number, then we'll get a certain color. So we can do system color foreground. F stands for the foreground, and then we put in a number. Okay. Let's see what's happening here. System is undefined. Let's see. There we go. Okay. So otherwise, we get a different color. That we can do color F1. Okay. So the color itself doesn't really matter, but just so you can visualize it, we're going to use those two separate ones, and then we're going to print out the value of, you can see it, value of the iterator. I is, and then we'll print out the value of I. Okay. So let's run that code and see what that looks like. Actually, let's add in a line break here. Maybe that'll be a bit easier. Just try that on your end. And there we go. So as you can see, it was switching the color every single time as it was going through that iteration. And it went 1, 0, 1, 2, 3, right up until we got to 19. Because once it gets to 19, it's true, but then on the next iteration, it will actually go to 20, and it would evaluate, okay, 20 is actually not lower than 20, so that would be false. So let's take it from the beginning and try to visualize this loop in our heads. So we set the iterator value to 0 as a starting point. So we're starting with 0. This first time, it would equal true, right? 0 is less than 20. Then 0 would be divisible by 2. So it would trigger this first color. So it would be an even number. It would trigger color F2. And then otherwise, actually, this wouldn't get run on the first iteration. And then we would print out the value of the iterator tracker is, and then I, and then a line break. Then at this point, we are adding 1 to 0. So the result is 1. So I is now 1. Then we get back to the top. Now we have 1 less than 20, and that would trigger true still, right? So we go on to the body of the loop. Is 1 divisible by 2? No, so we wouldn't trigger color F2, we would trigger color F1. And then we print out the value of I as 1 up until this point. Then we add 1 to the iterator value, meaning we now have I being equal to 2. And again, we loop back to the beginning of that while loop, and now we evaluate 2 less than 20. Is that true? It's true. So we keep going, right? We get into the body of the loop, and now we have 2 dividing by 2. So is that divisible by 2, right? Are we going to get a 0 remainder? And that's the case. Therefore, we print out F2. And you can play around with the parameters. So you could, for example, make this 100. It would go on a little bit longer, but let's check that out. You can see it's flicking back and forth between the colors. And there you go. So it went up all the way to 99, actually. So if you wanted to go up to 100, you would have to make that less or equal to. That way, when it does hit 100, that condition is still true. There you go. So try and have a go and change a number of things, get comfortable, try to make your own loops. Just play with code. That's really the best way to learn on your own. and making sure that that knowledge does stick, and rather than trying to remember the syntax. If you actually use the code and try to build your own loops, that's really when it's going to sticking in your head for you to remember it. So that's it for program number 2 of session 6. Okay, guys, so now for the next program, we're going to be looking at something called do while loop. So it's a new type of loop that I'll be introducing, and best way to show you is a live example, explain exactly how it works. And for that, we're going to be building a program that takes in a number and then determines if that number is prime or not, meaning it's only divisible by 1 and itself. Okay, so let's get into it. And we're going to need our preprocessor of IO string because we're dealing with input output. We're going to need our namespace declaration. Okay, and then we get into our main function. We have return type, the name of our main function, make sure it's not capitalized. And then we get into the body of that function. We are returning 0 towards the end of it as always. And let's get into it here and think about our variables. So what data are we interacting with? Are we going to store our values? So I guess we could create one called number to take that number that the user will enter, and also count of numbers divisible by, so that we can track how many numbers the original number is divisible by. So as you can see here, it should be 2. It should be divisible by 1 and by itself. That's how we know that it's a prime number. Okay. So then we output a message using cout, so requesting that number. Please enter a number, oh, and cin object to read that data entered by the user and store it in the number variable. Cool. We've got our number there, and now we can start to analyze it. So for that, we're going to use a do while loop. So we're going to do the following. And this is the body of the do while loop, right? So we have the do keyword that begins that loop definition. We have the body of the loop here, and then towards the end we have while, followed by the actual condition of the loop. Now, bear in mind that the condition itself is evaluated after the content within the loop is run in here. So it's just something to bear in mind when you're doing a while loop. If you will recall, the condition was up here, right? It was up here, and it basically looked. But if we are talking about a do while loop, then it's the opposite. You start with some code, then you have a condition, and if the condition is true, it will loop around a second time. So at a minimum, you know that this code will be run once, and then if necessary, as deemed by the condition in here, then it's gonna repeat and repeat and repeat. Okay, so for our condition, let's create a tracker for the iterations called I, and we're going to loop as long as I is less than or equal to the number that we are evaluating, because we want to check all the numbers from 1 up until the number that we're evaluating to see if the number is divisible by those. So we're going to check all those candidates, and we're going to increment as we go along. So I'm going to check 1 by 1. So I plus plus. If we don't do I plus plus and we find ourselves in a loop, or if we don't change the value of I, we're going to end up a loop that ends up going forever. So we need to be mindful of this when we're creating loops. How is the progression going to happen? Is it going to be an increment? Is it going to be a decrement? What's going to happen for the loop to move forward? So next, we check if the value is divisible. So let's output a message to let the user know that this is happening. Checking if, and then number is divisible by, then that's going to be I. Okay. So if that's the case, so if number modulus 0, so we're checking the remainder. Sorry, I. The remainder, if that's 0, that means that it's divisible, right? If that's the case, then we can increment this count because we know we found a number that is divisible. And we can also let the user know is divisible. Oh, so that's that. Let me just
Thanks for watching. Feel free to add your questions as comments down below.
add some line breaks so it doesn't get all jumbled up. So that's it for the do while loop. Now, you could get a situation, for example, if the user enters the number 1, where this code gets executed once, okay, I will now be incremented to 2, and it will evaluate, okay, 2 is less than or equal to 1, and that will turn out to be false, right? So that will be a situation where this code will run once, and because you evaluate the condition afterwards, the condition will actually be set to false at this stage, and you don't actually end up with a loop, technically, if you think about it, because it will run this code once and then stop. It will not continue looping forward. Obviously, we have a situation where, for example, you enter the number 5 in here. This code will get run once. I will get incremented to 2. And then you get a situation where you're looking at 2 is less than or equal to 5. And then, and only then, you know, when this condition is true, are we going to get a loop around effect. Okay, so it will only loop around that second, third time, fourth, and so on if this condition is true. Regardless of the condition, this will only be executed. This will always be executed at least a minimum of 1 time. So it's just one thing to bear in mind. The while loop, because you're executing that evaluation of the condition in the beginning, you could get a situation where you have a while loop and in the beginning the condition is false, therefore the code is never run or executed. But that's not the case with a do while loop, which is completely the opposite to a while loop. The do while loop will always evaluate the condition at the end. Therefore, it always runs the code in the beginning at least once. So it's just something to bear in mind when you're comparing the two, do while loops and while loops. So now we know how many numbers it's divisible by, so we can actually print out and determine if it's a prime. So if the number it's divisible by, the count of the numbers is divisible by is equal to 2, and we can do the message saying a number is prime. Otherwise, let's mix up. So cout number is not prime. And again, let's put some line breaks in there to make it look nice. Okay, so let's run that. Actually, one more thing, we need to initialize this value here for that while loop, otherwise we're gonna get an error. So let's start with 1, and it will loop from 1 up until the number that we've specified. So if we run that, and we actually start with 1, we get that situation that I was talking to you about. It actually only runs this code once. As you can see here, checking if 1 is divisible by 1. It is divisible, and this number is not prime because it's only divisible by itself, basically. So it's only divisible by 1 number. So 1 is not a prime number. And let's try again, but this time let's try 5, right? So it ran 1 time. It found out that it is divisible. And then because, you know, the loop was at 2, right? We haven't gotten to 5 yet. It continues looping around, and it actually ran this code, the 5 times, so 5 loops in total. And we find out that it is divisible by 5, by 1. So therefore, 5 is a prime number. Okay, so it's quite effective. It reacts accordingly. If you don't need to do it once, it'll do it once at a minimum. Otherwise, it'll continue looking forward. Okay. Okay, guys, so for our last look here in session 6 at loops, we're going to actually look at a program that uses loops within loops. And this can sometimes be a bit tricky to conceptualize and just visualize in your head, get your mind around it. But we'll actually take it step by step, and I'm going to show you ways in which we can figure out what's happening within the loop. Okay? So this is going to be a program that asks the user to enter a number and then determines the factors of that given number. So starting from the top, we have IO stream, which is going to be our preprocessor for input and output. Then we have our namespace declaration, and then our main function. So nothing fancy, nothing new happening so far. So hopefully that part is okay. Here we're just creating a integer variable to store that number that we get from the user. So we ask the user here with the message using the cout object, we're printing out to the screen, enter any number. And then using the cin object, we save that value in the number variable. And we can get started with a first loop, loop number 1. We know it's a loop because we are using the for keyword, so it's going to be a for loop. And then we have the parameters here defining that loop. So we're going to track the iteration with the I variable, which is defined here starting at 1. And the loop will finish if I is over 100, right? So as long as it's less than 100 or equal to 100, this will equal true. Therefore, the loop will continue. And after each loop, we will get an incrementation of 1. The body of the loop is contained within the brackets, so you can see that here. Okay. And we can actually print out the value of I to help us visualize what's going on behind the scenes, to help us visualize each loop. Okay. So let's see here with loop number 2. Okay. With loop number 2, this is happening within loop number 1. And this I value is getting passed on. So we've defined this loop as having the j variable starting at 2 to track it, okay? And it will continue looping as long as j is lower or equal to I, so the factor that we're looking at. And then after each loop, j will be incremented. So you can think of it as this way. You have a number being entered by the user, right? And then basically we're checking 100 potential factors, right? That could be appropriate for that number. So we cycle through those 100 factors and we're testing them out to see if we can find any factors within those, right? So at this point, on that second loop, we're looping through 2, through a minimum of 2, to the number of the factor that we're checking, okay? We're printing out the j value so we can keep track of that second loop and what we're doing in there, so which iteration we're on. And then we check if that number is evenly divisible by, if the number is divisible by j, right? So we're testing out that factor. And if it is divisible, we basically print it out to the screen. So we identify that number as a factor. And then whatever result we get from dividing the number by that factor, we make that our new number, right? Because we want to find out the factors of that factor until we can get to the point where, we can get to a point where the number is so small that we have no further factors that we can find for it, right? And that can happen if we get to 1, right? So once we get to 1, we know that 1 is always a factor. So then we go ahead and conclude the search. Now, as you will remember, loop number 1 was going up to number 100. So it was testing from 1 to 100 as potential factors of the number entered by the user, right? So what's the point on continuing to search if we've gotten to 1, right? The factors cannot get any smaller than that. So there's no point in continuing to search for a factor of 1. At that point, we can use the break statement or the break clause to finish that loop, okay? So if once that happens, we finish this loop, okay? And we end up back on the first loop. And here we can also check if number equals 1. And then again, we break out of that second loop. Right? So it's one way to finish the search earlier rather than wasting all that computational power. So let's give it a try. Hopefully yours is loading a bit quicker than mine. Let's see here. There we go. Now that's working. So let's try 18. Okay. So let's see, let's break it down line by line, what is happening. So we've got here the number 18. We're starting with our first loop. So the value is 1, right? Comes to the second loop, and the second loop completely ignores it because, as you will remember, we're starting at 2, and we're only looking at it if it's smaller than the factor, or I, which is 1. So that would get completely skipped over. Let's see here. Then we cycle back, and now I is 2. Okay, so then we actually get into the second loop because you can see the j there being equal to 2. So we're checking if 18 is divisible by 2, which it is. So 2 is now considered a factor. And remember, we take that result, 18 divided by 2 is 9, and we store that as our new number for which we are looking for factors. So now it cycles back because we got to 2, right? So now the first loop is equal to 3. And we're looking at the second loop now with j starting at 2. So checking if 9 is divisible by 2, it is. So now we're going to store the 3, the resulting 3, as the number for which we are looking for factors, right? So again, we're here it changed to 9 because we took the result of 18 divided by 2, which was 9, right? We wanted to see if 9 had any further factors. We got it down to 3, and now we're looking for factors of 3, right? So 9 is divisible by 3, and that's why it's listed as a factor here. And we continue checking if 3 is divisible by 2. No. Checking if 3 is divisible by 3. So 3 is a factor of itself. And then we finish the search, right? 1 is a factor. Factor search is over. 1 is a factor. And that's it. Actually, what we could do here is we can get rid of the first message because we only need to really print it out. And there we go. So that's it for our last look at loops within section 6. Hello and welcome, guys, to session 7 of our introduction to the C++ programming language. And we're going to be going over something that you'll see within C++ programs as struct. So a data struct is basically, or structure is basically when you create a group of variables in a way. Think of it as that way. Let's say you have a group of measurements, right, for a kitchen here, and the width is in feet and also in inches. So it contains both units of measurements. You'd want to keep them together as part of the width. But if you were to, give them all each their own variable, then you end up with a ton of variables and it gets messy quite quick, right? So a struct is a way to define the sort of structure that looks like this, right? You can use it for other things, but basically you define a standard, right? So if for measurements, we always expect them in feet and inches, then you create a grouping of feet and inches, and you can store that within the actual width. Okay. So the best way to understand it is to actually see an example. So I'll take you through it. I'm going to be writing a program that calculates the area of a room, so the kitchen that we're looking at right now, and it does that by multiplying the length and the width. And crucially, each one is made up of 2 measurement units being feet and inches. So that's going to be the complexity here that we want to tackle. So let's get into it. We start with our preprocessor, include string because we're dealing with input output, and then the namespace declaration using namespace standard. And then we can get into writing or defining our structures before we even get to the main function. We actually do this beforehand. So struct measurements, and then you define it. Say we have it's as integers, and then inches as floats. So right off the bat, we know that any sort of measurement that is defined within the program is going to follow this standard. It's going to have feet.
If you have enjoyed watching this video, please subscribe to our YouTube channel. Thank you.
In integers, and then it's going to have inches in float. Okay. Then we can define another structure for the room to represent the kitchen. And the room is going to have both length and width, right? And these are going to be measurements. So you can think of it as the data type, as a defining data type. That needs to be singular. We define it as singular up here. So as you can see, we are already encapsulating, or we're already making use of that first struct in a second struct. So basically, this length consists of a measurement, and a measurement consists of both having feet and then inches. So already we are using this here. So you can see how handy it can be right away. We haven't even started to write anything in our main function yet. So let's get into it. Integer main, as always. Then we return 0 towards the end. Cool. Now let's think about saving these values into some structures. So let's define our room as kitchen, and then let's store the length. Okay, so kitchen length feet equals 12, and that length inches equals 6.5, and store kitchen with that feet equals 10, and kitchen that length equals 5.5. So then we can calculate area. So area is going to be float. Area is equal to, and it's going to be total length times total. Let's define those here. Floats total length is going to be equal to the kitchen length in feet plus kitchen length in inches. Of course, we have to translate inches to feet. 12 inches make up 1 feet, and then we do the same for the width. So let's replace that. Okay. Cool. So then we can actually print out the result. Area of the is let me fix that, and let's see that in action. And there you go. So the area of our kitchen and room is 131.165, and that's exactly what we were expecting. So I hope you can see how we can set values using structures. It adds another dimension really to our variables, and we can also access them. So we can set them right separately. So we're setting the feet here. In here we're setting the inches, and then you can access them separately and use them throughout your program. So it's another way to organize your code and make it more robust. So that's it for session 7, program 1. Thank you very much. Hello guys, I'm going to be taking you through the solution of project number 1, your introduction to the C++ programming language. Now, if you do still find yourself getting stuck after we have reviewed the solution, if there's concepts that you'd like to cover in further detail, please refer to the material online. We also offer private tutoring, as I've mentioned before, so that is available to you. in order to speed up your progress. So just wanted to make you aware of those options. Now, without any further delay, let's jump into it. So this was supposed to be a program used to calculate the age of a person by entering the date of birth. So we start with our preprocessor, which is IOStream. So that's going to be necessary for dealing with inputs, outputs. If you get rid of that, instantly you start to get errors in your program. If you were trying to do inputs and outputs, then what the next bit is quite easy to forget sometimes, which is the namespace declaration to tell the compiler which sort of dictionary or set of keywords you're going to be using to define and write your program. Okay. Then we get into our main function, which is going to encapsulate all of our code that's going to actually be running there. And the first thing we do is start thinking about variables, right? Start thinking about what data are we going to interact with. So that's going to be some integers for the current day, current month, year, and then the birthday, month, and then the year, right? So essentially what we're doing here is we're subtracting the birthday from the current day, the birth month from the current month, and then the birth year from the current year. Then we store the results in DMY for day, month, year, respectively. And then we have here current day 2, current month 2, current year 2. That will come into play later on. You'll see why. It's just to store some intermediate calculations for the month, day, and year without changing the values for the original ones, right? So after that, we want to request that data from the user. We want to then collect it, right? We want to store it. So we're using the cout object and the insertion operator to then print out this message here on the screen. So enter the current day, and then the cin object and the extraction operator to store that into the current day variable, okay? So next thing we're doing is the same for the current month, then for the current year, and then we get the birthday, birth month, birth year. So we've got both sets of data, right? The current day, so that the program knows what to compare it to, and then we have the birthday, month, year. Okay. So that's it there. Now we can start analyzing that data and doing those calculations, given that we have everything that we need, right? And for that, we're going to be using some if statements. So I'm going to be going over the conditions that we've set and what we're actually doing with those, so that you can understand what's happening behind the scenes. So with this first if statement, the condition is that the birthday is before or equal to the current day. The birth and the birth month is before or equal to the current month. Or the birth year is before or equal to the current year. So it's basically this first condition that I've translated to you and one of these two. The birth month is before equal to the current month, or birth year is before or equal to the current year. And if that's the case, this is really the simplest of our outcomes. It's pretty straightforward. All we're doing, as I mentioned to you, is subtracting the birthday from the current day, birth month from the current month, birth year from the current year. But if it was only just that, we wouldn't have the rest of the program. And as you can imagine, the calculation itself can become a bit more complex with other scenarios. So let's go and cover those. But overall, the main thing I want you to just bear in mind is that all these different scenarios will revolve around these three calculations, right? So we're calculating the difference in day, the difference in month, and the difference in year. There's going to be slightly a few variables here and there. Don't let them confuse you. At the end of the day, this is all that we're doing. We're just accounting for different scenarios. The next scenario is that if birthday is equal to or before the current day, and birth month is after the current month, and birth year is before the current year. So in this scenario, we can just subtract the birthdays normally, okay? But then for the month, we need to subtract the birth month from the current month plus 12. Okay, so we actually add 12 to that current month because, as you can imagine, we cannot subtract December, for example, from November. That's not something that we can do, right? So to get around that, this is what we do. And then for the year, we have to adjust it because we've added 12 months to get the difference in months, right? But then for the year, we need to subtract an extra year. So we subtract the birth year from the current year, and then additionally another year to make up for these 12 months. So that's what's happening with this condition. So it's a bit of a tricky one when you have the actual birth month that's actually past the current month, because it does change that calculation just the slightest bit. The next one will be similar to that, and it will follow some of those same principles. But in this one, it's the birthday that is higher than the current day. So instead of the month, we have the birthday being past or after that current day, and we have the birth month being before the current month, the birth year being before the current year, right? So what do we do here? So if the current month has 31 days, which all these months do, then we add 31 days to the current day and then subtract the birthday, right? Then when subtracting the birth month from the current month, we subtract an additional one to make up for these 31 days that we've added to figure out the difference in the days, okay? And then the current year, because it is before, because the birth year is before the current year, there's nothing special going on here. We really are adjusting for the day, okay? And then we're adding, actually we're subtracting an extra month to make up for that adjustments. Now these if statements here will follow the exact same pattern. The only difference is that now we're dealing with months that have 29 days, with months that have 28 days, and in the case of the month has 30 days. So the current month has 30 days, okay? So that's it. And again, we're doing that same exact calculation, but because we have a few different things to adjust for, such as the day there and then the month afterwards, it can look a bit more complicated. But when you look at all this, really the only difference is that we're going to be adjusting for 31 days, 29 days, 28, and 30. So don't let the different if statements kind of put you off or frighten you. There's nothing really fancy going on there. It's quite simple once you go through it. So the next one, the next condition is likely the most complex of them all. And in this case, we have the birthday being after the current day. We have also the birth month being after or equal to the current month. And lastly, the year is fine. So the birth year is before the current year. So in this type of scenario, again, we're dealing with those days. We're adjusting for those days by adding them on when we're doing that calculation. So we add current day plus 31 before subtracting it from the birthday. But this time, and we're subtracting the extra month as we were before, right? But then in this case also, we are adding 12 extra months to deal with the fact that the birth month is after the current month. Remember, we cannot subtract December from November, so we need to adjust it by adding 12 months to the current month. And then we can always adjust that when we look at the year calculation, right? So just to recap, we're adding days onto the current day so that we can subtract the birthday. And then to fix that, we're adding that extra day that extra month that's being subtracted from the current month. But then we have the other problem of the birth month being after the current month. So we also have to account for that. And this is where these 12 extra months comes from, which we adjust by removing 1 year when we get to the year calculation. So if you've noticed the pattern up to this point, all these if statements, the only thing that we're dealing with here are scenarios where the birthday is after the current day. In this case, we add, we add a month worth of days to the current day to be able to do that subtraction. And then if you have a scenario where the birth month is after the current month, then we add 12 months to the current month to make that calculation possible. And then we're always adjusting. So in here, we added, we added 12 months.
Thanks for watching. Please like and share this video.
So we subtract one year to the current year to fix that that calculation. So again, it's the same as above here, but we're dealing with 29 days. Here we're dealing with 28 days. How do we know we're dealing with 28 days or 29 days for the month of February? We have to see if it is divisible by 4. If the current year is divisible by 4, then we know we're dealing with a leap year, so that's 29. Otherwise, we are dealing with just a regular year, and it's 28 days. Finally, we've got the months that have 30 days in here, which are all of these. And it's the same pattern throughout. We go ahead and we add 30 days to the current day, and we subtract the birthday. For the month, we actually have to go in and add those 12 months because the birth date is after the current month, and we subtract 1 to make up for these 30 days that we've added here for the current day. So it's just something that we need to bear in mind. And then lastly, we subtract 1 year because we've added 12 months when we did the month calculation. Okay, so after all that, we print out the results in the form of some statements. So we use the cout object, the insertion operator, to insert this data onto the output stream. And then we have the variable here for d, which represents the difference, and that will get printed out. Then we have nl, which basically ends that line, acting sort of like a line break, and we go on to the next statement. So as I mentioned here, let's do a quick recap. So we have our preprocessor namespace just kind of set up before we get to our actual function, our main function, which will run our code. And we're declaring our variables, thinking about what data are we dealing with, where are we going to store it. We then request the information from the user, we store it in our variables, and then we analyze it. We do the actual subtraction, right, of the day, of the month, and the year. If the birthday is before the day, the current day, if the birth month is before the current month, or the birth year is before the current year, it's really straightforward. We just do subtraction 1 to 1. It only really gets a bit more complex once we start looking at scenarios where, for example, the birth month is higher than the current month, meaning we can't subtract December from November if that was the case. And then we just add 12 months to the current month before calculating the difference in months, and we subtract an extra year when we're dealing with that. So it's the same principle that is later applied to days, where we add 31 days. For example, if the birthday is after the current month, and that of course depends on the current month. Does it have 31 days? Does it have 29 days? And so on and so forth. So that's been the solution for the project. Again, if you do need any further additional support, reach out to us on the platform, and help is available. Thank you so much. So we've reached the end here of our course at coding-bootcamps.com. So please feel free to check us out online, provide us with your feedback, and don't forget to follow along on social media. We're on Instagram, Facebook, YouTube. Make sure to follow us and show your support. So this was an introduction to the C++ programming language. We covered C++, its characteristics, an overview of object-oriented programming. We looked at fundamental types, data types, names, variables, constants, escape sequences, keywords, all which are crucial to the building of an application. We looked at arithmetic operators, if, else if, nested if statements dealing with the construction of logic within the program. We've looked at switch cases where you have one trigger and then you have multiple outcomes to choose from. If you recall, we looked at loops, so for, while, do while, and nested loops, with some examples to guide you as to the main differences so that you can make that decision in deciding which one you want to use for your program. We've looked at structures and just how powerful they can be, especially when you combine them together in organizing the data within a program. We've completed our first project into um, building a program to calculate the age of a human by entering the date of birth, and plenty of homework along the way. So, my side, it's been an absolute pleasure taking you along, and I can only wish you the best of luck on your development journey and offer my sincere congratulations on completing this course. I can only imagine it must have been challenging at times, but if you push through and you get to the end, congratulations. Final note on private tutoring sessions, we do have private tutoring available not only for C++, but other programming languages such as C. If you do feel that you need just that tiny bit of extra help to get you over the line or to get you onto the next stage of your development process, just reach out to us and help is available. Next classes after this would be the intermediate level C programming language with hands-on examples and the introduction to C++ programming. There's plenty of classes that we offer on the platform, so do check us out and stay tuned for any new classes coming out. Okay, so thank you so much for joining us and see you on the next class.